All right, last topic here is inverse trig functions, cosecant, secant, cotangent, and how they're related to the basic trig functions and working with ratios and angles. First thing here, looking at graphs of them. Let's this one first. How is y equals secant related to cosine? If you have the graph of cosine, which we will hopefully create pretty quickly here. Let's do that. Okay, this is going to be our graph here. Move down a bit, make a bit more space maybe. If we know where graph of cosine is, okay, cosine starts, let's make this 1 here. So cosine, and let's say that this is going to work for 2 pi here. 2 pi, 4 pi, and so on, right? So graph of cosine goes down like that, like this. Like this, there's one cycle. Same thing happens again. And it just keeps going, right? And so more or less, I missed the last part there, but and it keeps going like this. So how can you use that graph to figure out where the asymptotes of secant occur? They are going to occur, right, at the zeros of cosine, right? Secant of x, if you were putting it in your calculator to graph, you'd have to put it in as 1 over cosine of x. It's the reciprocal, right? Reciprocal of cosine. Drawing the reciprocal graph, first thing you would think about is where the zeros are. Where those zeros are, that's where the asymptotes are going to occur. So if all you care about is where the asymptotes are, just think where the zeros of cosine are. Pi over 2, 3 pi over 2, 5 pi over 2, like the odd multiples of pi over 2. Or you can write it as pi over 2 plus n times pi, the way you've seen before, because that's how far apart they are. Right? So everywhere you're going to have an asymptote. If you're going to actually draw the graph, you're going to have an asymptote right there, and one there, one there, and so on, and on the other side as well, right? Right there. If you're drawing the graph of this, then it's going to intersect right here, and you're going to have this U-shaped thing. As that one goes down, this is going to go up, and then this side here, it's going to open down here. And just that keeps repeating, right? It doesn't actually cross the graph, just they meet at 1, right? Because that line there is 1, and that line there is -1. That's where they meet each other. Alright, so if we speed this up here, not drawing very accurately, but close enough. Let's try that one again. These should all be symmetric if I was drawing them nicely. Think about what the period of that is. The period is going to be exactly the same as it is for cosine, right? Because however often this thing repeats, cosine repeats every 2 pi. That's one cycle of the graph. So the secant graph is going to repeat every 2 pi. That, and then it's down here, and then there, and then you're back to the point you started with, right? Or, you know, pick any point to the same point, right? Any point to the same point here, right? Like that point to the same point is 2 pi, right? Next, we're looking at graph of cosecant, and explain how it's related to graph of sine. Well, I'm actually going to cheat a bit here because it's basically the same as, it's going to be the same shape as the one up here. So let's copy this and paste it. We can think about how it's different, okay? So we'll copy that, and we're going to put it down here, make lots of space for it. Okay, now that's a graph of That's the graph of secant. To make it the graph of cosine, or to make it the graph of cosecant, reciprocal of sine. Essentially, if we have these axes in a different place, or I'm going to shift the whole graph over here, right? Because the graph of sine, if I just take that blue part there, let's try that again. If we take just the graph of this, it's not going to work. Well, maybe if we're lucky it will. There. Okay, so the graph of sines actually looks like this, right? It starts in the middle on the way up here. It starts in the middle, goes up, down, down, up. That's the graph of sine, right? It's the same shape. Everything's the same about it. So all that's going to mean is these things are all in a different spot, but the same shape here. That's all going to be over here. Asymptotes are going to be 1 over. And then, of course, I missed these ones. Those will be over there too, right? That graph's going to be exactly the same shape, just in a different spot, right? The asymptotes for this are actually easier to explain how or where they are, because these were the asymptotes for the secant graph, because there was 1 at pi over 2. These are going to be slightly different because if you look where they are, there's 1 at 0, right? There's 1 at 0, there's 1 at pi, there's 1 at 2 pi, right? Because that's where the zeros of sine are. Sine hits 0 every multiple of pi. So it's easier to write where these are. They're just multiples of pi. So you can just say n times pi, where n is an integer. If you're talking about where the asymptotes are. Those are related because they're reciprocals of each other. Where the graphs of cotangent and tangent intersect, well, you could draw the two of them. At this point is probably the best strategy. You should probably know, though, you can think about it from the triangles. We'll make that connection in a second. Let's draw the graphs first. See if we can see what they look like. Tangent graph. We need some asymptotes at where tangent is undefined. Let's make this 2 pi again. Same scale as before. Whoops. 4 pi and so on, right? 6 pi. We got negative 2 pi over here. If we're continuing that far this way. If you're drawing the tangent graph, then it starts at 0. And it is asymptotic at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. On this side, right there, right there. If you're looking for where that graph is, where tangent is undefined. Tangent's undefined. If you think about the unit circle, just draw it over here temporarily. Maybe not in gray so you can see it. If you think about the unit circle, okay, there's a unit circle. As you go around here, you draw the triangle anywhere. Tangent's y over x. Tangent's going to be undefined when x is 0, which is basically angles that are vertical like that. Alright, so 90, 270, and so on, right? If you're trying to draw this now, it goes up that way and down that way. And that pattern just keeps repeating here. Keeps repeating. This is the tangent graph. Oops. Probably enough to see where it intersects. If you're drawing the cotangent graph, it's the reciprocal of that. They're going to intersect where 1 happens here. Now, I haven't probably drawn this very well. But this cotangent graph is going to have asymptotes at a different spot, right? It's going to have asymptotes where this thing is 0. It's going to have asymptotes right here and right here. If you're drawing the cotangent graph, reciprocal of this one. and so on, okay? It's got asymptotes 0, pi, 2 pi, the same way as the cosecant graph does. If you're trying to draw this one, it is going to be, it's the reciprocal of this, right? So it's going to cross right in here. No, I didn't draw this all that well, but this goes down when that one goes up, and this one hits 0 when when the tangent graph has an asymptote. Tangent graph has an asymptote, it hits 0, and then it's gonna exactly the same shape in there. Okay, where it actually crosses is halfway between there, just because of the symmetry. Crosses halfway between. This thing's gonna be the same thing here. Oops. No, I didn't actually intersect with the right place. I realize now, according to my scale, because my graph that I drew in black wasn't all that great. Let's try again here. Let's zoom in on part of it, and then we can do a better job of this. I'm trying to figure out where this graph, draw this curve better here. That one goes up like that. Should actually be 1 right there. Sorry, this should actually be 1, and that's pi over 4. That's where it's going to intersect. It intersects right there. Okay, hits 0 there, and it's going to hit, if we were drawing this accurately, if we want to get the right shape there, this thing's going to hit, oops, try that again. Okay, I've been drawing it too curved. I've been drawing it like an x cubed graph here. And if you just keep drawing that shape there, that's a good point to know at 1 there, right? There's that tangent graph. Just keep repeating. And then the cotangent graph's gonna come down like that. Each time hit 0, cross there. Okay, this one comes down in the middle there. You get a nice shape for the thing. Alright. They're gonna cross right in the middle there, okay, because of the symmetry of the thing. The other way you can know where they can and make the connection to those special triangles that you have come to know and love, I think. If you have that 45-degree triangle, 45, 45, 90, or pi over 4, that's where these are the same. That's where the tangent is 1, right? Tangent of 45 degrees, pi over 4, is 1. 1 over 1, right? That's the same place where the cotangent of pi over 4 is 1. That's where they're the same, right? Pi over 4 is where they have the same tangent and cotangent. So anytime you have an angle related to pi over 4 here, that's where they're going to intersect. Because if you have a tangent of 2, if tangent was 2, cotangent is a half, right? Because they're reciprocals of each other. The only time they're going to be the same is when they're 1 or negative 1. So anytime on here where they hit 1 or negative 1, and those angles are going to be halfway between the zeros of each of them, all right? One of them is always 0 every pi over 2. They're going to cross each other halfway between there, all right? That was a long way to get to thinking of where they cross each other. Mainly just to look at the graphs was the intent of that. What's the value of secant of 2.5? 2.5 is an angle you got to work with on your calculator. I would just put it all in as one thing here, cosine, 1 over cosine of 2.5. If you have your calculator set in radian mode, you can just punch it in directly and see. That's not what we want. Make sure it's in radian mode. 1 divided by cosine 2.5. Or, of course, you could go cosine 2.5, and then you can go 1 divided by that answer. You get the same thing, right? Negative. Cosine's negative, so secant's negative. This is in 2.5 is in quadrant 2, right? So let's remember this, negative 1.248. Let's actually just take a typing of this, so we can use it. And we can have a look at here as we work with this. Secant of that is, it's 1 over this number, right? Negative 0.8011. You do the reciprocal of the ratio, okay? You don't do the reciprocal of the angle. That's what it is. Secant's got to be bigger than 1, always, or equal to 1 or negative 1, because cosine can't be beyond that. Cosine's always between 1 and negative 1. It's never bigger. Most common wrong thing to do here would be saying it's cosine of 1 over 2.5, which is going to spit out something on the calculator, but it's not that. You don't flip the angle over, you flip the ratio over, right? You work out the ratio, then you do the reciprocal of that ratio, right? That 2.5 is the angle. Determine the value of cosecant 7 pi over 6 without a calculator. Use one of your triangles, right? Your exact ratio triangles. Oops, that's not right. That is definitely not a triangle. So we'll draw it roughly here. We want pi over 6 because that angle is related to pi over 6. Wouldn't hurt to put it in a little quick drawing here to get your bearings. 7 pi over 6 is over here somewhere. And we have this angle over here. Quadrant 3, 7 pi over 6, right? That's pi over 6. So we need to know, first of all, quadrant 3, cosecant is negative, since sine is negative, right? Both of them are negative in that quadrant, right? Because they're related to each other. If you know that this is 1, 2, and a root 3 down here, I would start by just thinking sine of 7 pi over 6 is negative. Which way do you have to look at that triangle? It's going to be the same as pi over 6. Sine is 1 over 2. So this is negative 1 over 2. So cosecant 7 pi over 6 is going to be negative 2 over 1. Or, of course, negative 2. All right? And then we have our last thing here. Evaluate cotangent squared of 2 pi over 3. Well, you need that same triangle up there, only we're going to have to look at it. Let's bring this triangle down here. Use that again. If you're going to use that triangle for this, oops, lost our 2. Except we don't want this angle anymore now. We want a different angle in there. We want this angle now, right? Pi over 3, because we have an angle that's related to pi over 3. I would start by saying, I mean, you can work one way or the other. You can start by changing this around to get to something you can work with there. But we know it's related to tangent of pi over 3, so maybe just write down what tangent of pi over 3 is first. Tangent of pi over 3 is opposite over adjacent, right? Those two sides there. You have root 3 over 1 if you really want to, but it's just root 3. So cotangent of, well, let's actually write, let's take our 2 pi over 3 first. Since we're in quadrant 2, 2 pi over 3 is in quadrant 2, right, over here. Since we're in quadrant 2, we got negative for tangent. If we want now what cotangent to cosine, if you want what cotangent of 2 pi over 3 is, it's going to be negative 1 over root 3. And we want it to be squared now, right? So we need to know what this is squared. I'm not sure why I keep writing that. Cotangent 2 pi over 3 squared is just that number squared, 1 over root 3 squared, which is going to be positive 1/3. Right? That little thing just means figure out the ratio first. Okay, figure out that ratio first and then square it. Alright, good luck with all the studying.